Antarctica is the most southerly point of land on the globe. It covers an area larger than Australia. It's the coldest continent on the planet and is constantly covered in a layer of ice, holding the record for the lowest temperature ever recorded on the Earth's surface at minus 89 degrees centigrade. But although Antarctica is frozen and almost uninhabited, people still come here to undertake geography fieldwork. A glacier is a huge sheet of ice formed of compacted snow, which often fills whole valleys. Glaciers cover 10% of the world's surface, wherever summertime temperatures don't rise enough to melt the winter snow. In Antarctica, where temperatures rarely ever rise above freezing, there are some huge glaciers for scientists to study. Their project is looking at holes in the ice called cryoconite holes. These are caused by dust and dirt settling on the glacier. The dust absorbs the sun's heat. The warmed up particles then melt a hole down into the ice.
As more of these cryoconite holes develop, then they're going to create, essentially if they join together, they'll create rivers either on the surface of the glacier or beneath the glacier. And then when those rivers begin to form, then they lubricate the bottom of the glacier, which actually causes the whole thing to move much more quickly. So it's linked up with issues to do with climate change and global warming.
It's the abundance and distribution of these holes that they're measuring incrementally.
As geographers, we're interested in distributions and patterns, whether it's your population distribution across the country or across the world or things like that. So the idea of looking at the distribution of the cryoconite holes was to see, was there a pattern? Were they evenly distributed? Were they unevenly distributed? Were they in a very random pattern? Was it a very regular pattern?